Solids of revolution. Find the volume of the solid formed when the shaded region is rotated around the x-axis. Use disks and shells. So I want to see both methods. I'll make a separate video for each. Okay, so what's going on here is we're rotating this around the x-axis. This axis right here is what I'm rotating around. And rotate around the x-axis means that, let me change colors, rotate around the x-axis means that I'm going to take this shape and go around this area. It's not going to be quite a cone. This right here will be sort of the tip of it, and I'll get a shape like this. Not going to be quite a cone. It'll be a little bit curved, maybe like a sideways Hershey kiss. But that's the basic shape. So let me sketch that shape right here so we can get a better idea for it. So I get this sort of parabolic shape right here as the sides. I get this curve right here as the sort of area around it. Now let me see if I can make this look a little bit nicer. So you can see that it has this sort of solid curve, maybe, and okay, so that's pretty good. So you can see it's got this sort of curvy shape, and behind there we can see how it goes around, and this x-axis, I should have probably done this first, will go right through the middle of it. Okay, so that's the shape. Now, what we're actually going to end up doing is this. I need to use disks. And so if I were to look at this graph at any x value, I would have this measure right here, which I'm going to call R for reasons that should be very apparent shortly. Now, in here, in my sort of solid over here, this is this shape right here, and what that gives me is if I were to cut this solid, I would get this sort of disk right there, okay? That's the disk method we're going to use. And if I were to turn this around and look at it dead on, I would get a circle with radius r. Okay? And the idea I'm going to use is the volume of any object, the volume will equal the integral from some starting value to some stopping value. Let me leave those as a and b for now. We'll talk about why that's 0. Of the cross-sectional area with respect to x dx. And this is a solid of revolution, so what we actually know is that this cross-sectional area, the area of one of these circle cross-sections is going to be, so the area in terms of r is going to be pi r squared. This radius at any x value will actually end up equaling the y value. It's this height right here. So the radius will equal the y value, which is negative 3/16 x squared plus 3. Okay, so my area in terms of x will equal pi times my function, negative 3/16 x squared plus 3. I'm just writing over this graph in a lovely sort of way, squared. And I'm going to use this in my function. So we know that we have the integral. Okay, starting and stopping. Well, we can see clearly that we start at 0. And I gave you a nice graph. You should be able to see that we stop at 4. But if you're not quite sure, let me go into red. So if you're not quite sure where this endpoint is, it's where y is 0. So I can solve for where this is 0. So let's do 0 equals negative 3/16 x squared plus 3. I'm going to move that to the other side. 3/16 x squared equals 3. Multiply by 16/3, x squared equals 16, and take the square root. X is plus or minus 4, but my minus 4 I don't care about, so I'm going to use this positive 4 as my other limit of integration. So from 0 to 4 of the areas, which are just, I'll use that yellow, pi multiplied by the radius squared. The radius is the height of this function, so I have pi times negative 3/16 x squared plus 3 squared dx. And we actually had a formula in class. This is a constant multiple. Pi multiplied by the integral from this case 0 to 4 of negative 3/16 x squared plus 3 squared dx. And we could go after this by hand, but we have a calculator, so let's just go to the calculator and turn it on, make sure it's all up and running. Okay, so I'm going to put in pi times math, 9 is where I get fn int, times the integral of, parentheses, negative 3 divided by 16 times x squared plus 3, close parentheses, that's the radius, squared, comma, x, comma, 0, comma, 4. And so long as I didn't make any mistakes, let me see, so I have negative 3/16 x squared plus 3. I'm going from 0 to 4. I have this squared. I have a pi. So I should get approximately 60.319. So approximately 60.319. Final answer.